Good morning. I'm going to try to make sure that everything's up. There we go. A little bit more light. Now, as you check in this morning, that'll be good. Just say your highs and hellos, and let's get you checked in. Okay. We got one. And Austin and Alex are both up and ready to go. Way to go, seniors. Not a way to be starting off the morning bright and early. All right, who else? Oh, Jada, hey. Good morning there, young lady. And Trevor's here. That's nice. Starting to wake up. Got a few more to go. The easiest way to go is get in the morning. Laura and Christy, hey, good. Good morning to you ladies. And Ethan, yes. I see you on the phone here. Come on, we need a few more people awake. We've still got some time. Oh, Connor, good morning. Isabel, hey, great. And Janie and Maddie, they still got a couple minutes here before we get started. You might as well get your books out. We're going to go to page 774. But you might as well get your books out. Okay. 774, yep. This went pretty good the other day when I tried it with the class. So. Okay, I should be getting Janie and Maddie on board pretty quick. I see some more numbers went up. We got 2 minutes yet. Remember every morning to make sure you check in somewhere between 7 and 9 o'clock in the morning with me, just so we can get going. And I don't care when you check in. Those people that were late yesterday, I do care about that. Somewhere between 7 and 9 o'clock to check in with me. Make sure that you're still okay. I'm just kind of your okay counselor. Making sure everybody's doing well. All right. Got a half a minute here. Come on, Maddie and Janie, if you're there. Say hello. Or give me a call on my phone, 206-0491. Oh, okay. All right. Well, I don't see Maddie and Janie signing in yet or texting me yet, but we're going to start. We're going to talk about infinite sequences, okay? Infinite sequences. And what is an infinite sequence? Well, an infinite sequence is one that never ends, of course, and most sequences or series are. But there are one, oh, hey, Janie. Okay. There are ones that are different, okay? And we're going to talk about a limit. And here's what it does. Here's what it does. Let's say you're on a football field and you run half of it the first run. You run 50 yards. Then you run 25 yards. Then you run 12. Then you run 6. Then you run 3. And eventually, when they didn't have replay in football, they just call touchdown. Okay, that's what a limit does. You eventually get so close to a number, we just say it's that number. Like you might be at 4.00000000000000001. Really, how close are you to that 4? You're just at 4, and that's what a limit is. And there's some simple rules to limits that you need to know. So, get out a piece of paper. I'm going to give you just a few seconds to have a piece of paper. You need to know, and you need to write this down. You need this for your notes, for your test later, and we're going to use it a lot. Few rules about limits, okay? Few rules about limits, and here's what it is about, okay? If you have, and we'll get started, okay, if you have any values, we have a formula like 1 over n. Anytime the value on the bottom is larger, and anytime there's a variable that's larger on the bottom than it is on the top, it goes to 0. So I can have n to the 7th, 7n to the 7th plus 6n squared plus 8, but on the bottom I have, let's just say, n to the 8th. Because the bottom is a larger power, you only look at the bigger numbers. You don't look at the other numbers. You can just wipe out these numbers here. They don't matter. And you look at the powers. This one is to the 7th. This one is to the 8th. Anytime the bottom is larger than the top by power, it goes to 0. Because think about it. Even if I put it on 100 there, and I take 100 to the 7th power, the 100 to the 8th power, it's going to be a lot larger. Even though I multiply by 7, it's going to be a lot larger. And eventually, you're going to have like 1 over 100, 1 over 1,000, 1 over 10,000 when you start reducing them. And eventually, it's going to go to 0. So anytime the number on the bottom or the power on the bottom is larger than the power on top, it is going to go to 0. Okay? First rule. Okay? So if the bottom power is larger, it goes to 0. Okay? So if the bottom power is larger, it goes to 0. First rule. Second rule. If the powers are the same, so let's say I had 4n squared plus 8n plus 7 all over 6n squared minus 25. You only worry about the highest power. So I'm going to wipe out everything else. I'm just going to put lines through it. I don't need it. I don't need any of that. I'm just looking at this. Now, if the powers are the same, so it's to the same power, the powers are the same, or to the same power, however you want to say it, then it is the coefficient value. So what that means is it's just whatever's on front. 4 over 6, that's my answer. Or 2/3 if I reduce it. Okay, it's the coefficient power. It's whatever numbers are in front. Okay, it's coefficient power. So it'd be reduced to 2/3. If there was nothing here, that's really like a 1. If I had just n squared, it'd be 1/6. If I had an n squared on the bottom, it'd just be 4. It's the coefficient power. So That's the second rule. If the powers are the same, then it's the coefficient value. Okay? So, rule number 1, if the bottom power is larger, it goes to 0. Rule number 2, if the powers are the same, then it's the coefficient value. Rule number 3, if the power is larger on top, it goes to infinity. Goes to infinity. Plus or minus infinity. Just depending. If it's a negative on the top and a positive on the bottom, then it go to negative infinity. If they're both positive, go to positive infinity. If they're both negatives, they go to negative infinity. So for instance, it'll look like something like this. You end up with n to the third over an n to the second. I guarantee you that is going to infinity. And because they're both positives, it's going to positive infinity. Now, if there was a negative out in front of one of these, then it would be going to negative infinity. Okay? You got to watch that. So it just depends on, you can know the rules, a negative over a positive, or a positive over a negative, go to negative, two negative, positive. But that's the rule. If the power is larger on the top, then it goes to infinity. All right, now we're going to look into your book. We're going to look at a few of these, okay? Just a few of them. So if you would please, if you wake up this morning in time, okay, we're going to look over on page 776. 776 at example number 2, and it's 2a that we're looking at, okay? And it says we have 1 over 3n squared, and then they write this, and they always write it this way, 1 over 3n squared all over n squared, or 1 plus 3n squared, 1 plus 3n squared all over n squared, and they say the limit as n approaches infinity. That means all the numbers are just getting bigger and bigger. That's this part right here. The limit as n approaches infinity, it just means as this gets bigger. Now, we only have to concentrate on the biggest powers. Well, the biggest power is this n squared down here and this 3n squared. All the rest of this doesn't really matter. You only worry about the biggest power that you have. All right? And then you ask yourself, are the powers the same? Well, yes, they're the same. So if they're the same, it's the coefficient value. So we'd have 3 over 1, which is 3, and we're all done. That's how easy these can be if you just think them out. Look at the next one down, the b. The powers that we need, again, are 5n squared and n squared. They're the biggest ones, so it's 5 over 1, which would be 5. Then look at number on page 777, example number 3. They have a 4n squared at the very back end, and they have a 2n on the bottom. So they have a 4n squared and a 2n. Well, what do we know? The top power is greater than the bottom power. If the power is larger on the top, it goes to infinity. And what infinity? Well, you have a positive over a positive, so it's positive infinity. Not hard at all. It's just a matter of recognizing what they have. Now, here's where it gets tricky. Look at 3b. Everybody look at 3b in your book. This one you need to look at. They have a negative 1 raised to the n power, all to the n, all over 8n. Okay, this one is tricky. This one is really tricky, okay? Right here. If you put 1 in there, we know it's going to be 1/8 because we have n over 8n, so it's going to be 1/8. But what is so tricky about it is this negative. If you put an odd number up there, it's a negative. If you put an even up there, it's a positive. So it's going to go negative 1, 1/8, negative 1/8. And it's going to keep rotating like that. And this, we say, a limit does not exist. It never goes to one number exactly. It keeps rotating from a positive to a negative and so forth. It just keeps rotating, negative, positive, negative, positive. That's because of this -1 to the nth. And a lot of times you see that. Put that in your notes, -1 to the nth, that keeps rotating, a negative, positive, as you put numbers in. And so we don't say that any limit exists because it keeps rotating. And sometimes that happens. Okay. Now on the next page on 778, page 778, does everybody have this? Number one, bottom powers, when they're larger, it goes to 0. If the bottom power is larger, then the problem goes to 0. If the powers are the same, then it's the coefficient value. And if the power is larger on top, then it goes to infinity. And you might want to know positive or negative infinity, depending on the values. And then a limit doesn't exist, especially if you have that -1 to the end, where it rotates negative, positive, negative, positive. So everybody have this. Okay, so here's where you have to answer. Okay. We'll talk about 0 in just a second, Alex. Okay. All right. All right. All right. So now let's talk about this. How do you find the sum of an infinity series? You can find it, but only geometric series work. Only geometric series work, because think about it. If I'm doing an arithmetic series, wouldn't it be like 2, 4, 6? It'll never end. It's going to go to infinity. To add them up, you'll never get to it. It's just infinity. If you're subtracting by the same power, then it is. So no problem, okay? No problems whatsoever. Arithmetic, can't do. Geometric, we can do. But there's a key here for geometric, all right? Your rate, your R, has to be greater than a -1, but less than a +1. It's got to be some kind of fraction. So if you remember, your R value for geometric is your second divided by your first term. That has to be a fraction. It has to be a fraction. If it is a fraction, then it's an easy formula. The sum of numbers, okay, the sum of numbers is just the first term over 1 minus R. And that's the value of it. I'll give you a perfect example of this problem. They have one on the next page there. They have 21, -3. Then they have 3/7. Okay? This is the formula. So we can tell they're dividing by a -7 each time. Okay? So really, you take the second. So you get a -3 over 21, which is a decimal, which is, it's greater than a -1, less than 1. It fits in here. It is a decimal. So if that's the case, it's a decimal, we can do it. We take the first term, all over 1 minus a -3/21, plug it in on your calculator, and you have your answer. Okay? But the biggest thing is for the sum of numbers formula right here, you've got to know this little part right here. You got to know that the ratio is a fraction. The ratio has to be a fraction. If it's not a fraction, let's say it was like you did 2, then 6, then you're multiplying by 3, so you get 18. And if we're trying to add these numbers up, it'll never work because this keeps getting bigger and bigger. And if you divide the second by the first, 6 divided by 2 equals 3. That is greater than 1, can't work. So there's only certain ones you can do. So for the geometric, you can only do a certain amount of ones. Okay, then everybody, look here on page 779. On the very bottom, example number 6. It says 0.6 or 0.762, and they want you to write it as a fraction. Grab your calculators. Oh, I left mine over on my desk. 1 second, I'll be right back. I'll grab it. Make a big trip over here. All right, on your calculator, what I'd like you to do is just type in a whole row. If you don't remember how to do this, when you're doing repeating decimal, all you do is type in the repeating decimal part. So 0.762, 762, 762, 762, 762. You got to fill up one complete row. So I filled up one complete row. And now I hit math. And then just hit enter, enter. And your calculator will do it for you. 254 over 333. So I don't even do their formula. That's a waste of your time. You have a calculator. My goodness sakes, use your calculator. Let's try one. I'm going to try one. And everybody's got to write your answer. So type in your answer to the nearest 10th. All right, we're going to do 0.18 repeating decimal only on the 8. Repeating decimal only on the 8. 0.18. And then once you get your answer, type it in. Okay, so what are your answers? Type it in real quick. You had 0.18. See, you need your calculator. Oh, there we go. Laura, Austin, Isabel, Jada. Christy found it. Alex found it. Because if you don't practice it now, we're going to be in trouble when I ask you to do it later in the assignment. And the key here is to type in 0.1 and then all the 8s afterwards. That's what I did. And then I hit math, enter, enter, and I got 17 over 90. All right. So 6 of you answered. That means the rest of you had to find your calculator or grab it from wherever it was at. Okay, Soul Hunter got it. I'd like you to type it in so you practice it. Okay, let's do one more. Everybody should have your calculators by now. Yeah, 17 over 90. Yes, Ethan Hoffman. All right. Okay. Oh, and John, your calculator's upstairs. I left it on the kitchen table. And that's okay, Ethan. I can still get it. I got it on my phone. I leave my phone up here just in case you can't text. All right, let's try this one. We're going to try 0.351 repeating decimal on the 5-1. 0.351 repeating decimal on the 5-1. Okay, Christy got 58 over 165. John got 58 over 165. Jada, same. Laura, same. Austin, same. Isabel, Alex, Alex, you got 58 over 195? Or did you just hit the wrong thing? You meant 165. Oh, yeah. Okay. What about the rest of you guys? Are you even awake out there in La La Land? Okay. All right. All right. Well, you're graded on participation in this class too, a little bit. I added. Same thing. Oh, there you go, Ethan. Okay. You got to know where your stuff is. You should always have your calculator. All right. So your homework, go over to page 780 and 781. Okay. 780, 781. All right. We are going to do in the book. I just had to look it up here. Starting with problem 5, and you're going to go through 39. Now we're going to skip a couple problems. These are not bad at all. Number 1, those are 5 through 7. That's just limits, knowing your limit rules that I had up here. 8 and 9, that's repeating decimal. 10 through 12, that's doing the sum of the infinite series. And the same thing goes through. I'm going to let you skip 13. Okay? I'm going to let you skip problem number 30 because it gets a little hectic in there, but that's it. You are going to skip, again, 13 and 30. 13 and 30. Now, because it is our Friday of this week, I do have my trusty card deck up here. And if one person can identify the correct card, and you have to have them up before I draw the card, so everybody has to participate. All you have to do is say like 4 of clubs, put a 4C down. Or if you want a 3 of diamonds or a jack of clubs. If one of you, no, I'm not going to cheat. I'm going to have the cards up front, John. If one of you can guess it right, just one of you. Okay, Ethan's in for 7 of spades. You guys don't want to take that. It's going to be the top card right here. I'm not changing it. So get your guesses in. If one of you can do it, it's evens. So everybody get your guesses in. Ethan Hoffman has 7 of spades in. Hurry up, get your guesses in. I'm going to turn this card. Alex, 8 of hearts, 3 of diamonds is taken by Laura, 8 of spades by Austin, 8 of diamonds, 8 of clubs. Wow, you guys are thinking 8s? My goodness. 4 of hearts, 6 of clubs. Anybody else want to guess? Trevor, you might want to guess quickly. I don't know where the rest of the students are, but Isabel, 8, yeah. Jada, Christy, John, Laura, Maddie. Oh, Maddie is awake. 6 of hearts. Trevor, last chance. You don't have to spell it out, Trevor. You can put a, C or a D. All right. I don't think Connor's awake. All right, here we go. Queen of shards. Tricky little guy, aren't you? All right, here we go. The flip is 8. How did you guys know? That sucks. The odds of that are pretty good in my favor. The odds of you winning. I wonder what the next card would have been. 10 of clubs. Nobody guessed that one. I wish I would have picked that one. All right, well, lucky Alex Boats, you have created the nice evens for everybody in the class. Worked out nice for you. Now, remember, we have class on Monday next week because we have class every other day. So this week we had the Tuesdays and Thursdays. Next week it'll be Monday, Wednesday, and Friday. Remember tomorrow, check in. I do not want to call you guys in the morning. I hate doing that. So make sure that you do that. By the way, just to let you know, anybody that did not vote, you have all the problems. I said it was class participation, and I meant it. That's so if you didn't sign in and you didn't log in, you could have texted me. There was no excuses, or done something like that. Now, I am going to check with Janie because I know her computer sometimes doesn't work right, but I will check with her. But Connor should have been up doing this, being part of the class right away. All right, so I'm going to let you. Is there any questions? Any questions at all? Last chance? Okay, you guys have a great weekend. Shovel that snow that's out there. There's about 4 to 6 inches right now, I think. But it's going to go away by next week. So it is what it is. And stay safe. And practice your social distancing, they call it. Nobody's around up here, by the way. So I'm really social distancing. All right, well, have a good weekend, and we'll talk to you guys later. Get your homework done. Turn it in. 3 of you haven't turned it in yet, just so you know. All right. See you later. Bye.